Hello everyone, this is me again, Assam Hilmi, success partner with OBA Energy, and I will be your moderator in today's webinar. Today's webinar titled ESP, Scaling and Plugging. It's important to mention that this is the 77th free webinar provided by OBA Energy as a series of free webinar and knowledge share with our audience. So if you'd like to review or revisit all these webinars, you will find them on our YouTube channel. It's also important to mention that our guest speaker for today's webinar is Engineer Abdullah Higazi. As well, Engineer Abdullah is one of our distinguished lecturers with OB Energy. He has conducted several webinars with us. So you will find also these webinars on our YouTube channel. Before starting today's webinar, I'd like to give you a short presentation about our upcoming services plan. But before that, I'd like to mention that more than 50 days ago, the war in Gaza started. So I'd like to mention that we stand with Palestine and pray for their losses. So I invite you all to spread the truth and share the word with everyone around you. So before starting, this is our 10th wave of courses during November till January 2024. Four important and interesting courses: stock pipe prevention, electrical submersible pump, well integrity management system, and polymer injection using modeling using CMG. You can find our early bird discount here. The prices, and you'll also find our group discount, package discount for all these four courses as well. It's important to get this huge discount. If you'd like to register in any of these courses, I will share with you the link in the chat area. And you can also scan the QR code in front of you on the screen now as well. It's worth mentioning that we have conducted more than 30 live courses that are now available as recorded courses on our unique website. These courses come in different categories like reservoir engineering, production technology, rig and rigless operation, open and cased hole logging. Also, you can enjoy all our discounts on these courses. And the most important offer that we have right now is that all in all discount, we have a discount up to 60% on all of our courses. And if you'd like to get also a category discount for all the courses in that category, this is also available, as you see in the screen now. Here is also a QR code for our big sale. As I mentioned, all in all courses available with up to 60% discount. And also the same link is in the chat area will help you to register in these courses. Some few rules before starting today's webinar. I'm sorry for muting all your microphone, and please keep your camera off for better understanding of today's webinar by all of the audience. If you have any question, please put your question in the chat box, and I will be more than happy to read your question out loud to our instructor by the end of the webinar to get the answer. If you are registering in this webinar using a name like Galaxy or iPhone or something like this, I really encourage you to rename yourself as we will be sending certificates of attendance 1 week after today. So certificates will be sent 1 week from today. Just short introduction for our guest speaker for today, Engineer Abdullah Higazi. He is a senior petroleum engineer with more than 12 years of experience in the field of production technology and artificial lift systems. He is a senior production technologist at the Vitco here in Egypt, partnership with GB with Chiron. He is a freelance instructor with multiple teaching and monitoring experience online. He has a bachelor's degree in petroleum engineering from South Carolina University, graduated in 2011 with very good honor. His areas of experience includes well deliverability, well completion, intervention, artificial lift systems, well, and network modeling, and a lot to of this experience to be included in some of our courses by Engineer Abdullah, like perforation design and artificial lift ESP, ESP special course on our website as well. So, Engineer Abdullah, thanks for joining us today and sharing your knowledge with us. And the stage is yours to start the webinar. I think you are muted, so please unmute yourself.
Thank you, Assam, for the great introduction. Today, inshallah, we'll be discussing the ESP scaling and plugging issue, which is one of the major issues that we encounter in the ESP operations, which severely affect the ESP performance and run life. So our session would be around 15 to 20 minutes. Then we'll have an open discussion. If you please can share your thoughts and questions at the end 10 minutes of this session. So I'll start by sharing my screen. So electrical or electric submersible pump, ESP, is one of the major artificial lift systems that is known by the reliability and the high flow rate, creating high drawdowns. One of the major issues for the ESP is the scaling and plugging, and we will touch these two topics today quickly. Our agenda for today will discuss ESP scaling and plugging. We'll have introduction, ESP components, and on which components we expect to have the scaling and the plugging issue. Then we'll move to dig in more details in the scaling and the plugging problem, the types of scale, the differentiation between scaling issue and the plugging due to poor clean out, post well intervention and workover operation. Then we'll move to how to tackle the issue. I mean here that we will touch the scale inhibition and scale treatment. Okay, again, I remind you to keep the cameras off and the mics off, please. How to tackle the scale and the plugging issue, the advances and the scale inhibition, and we'll have at last 10 minutes open discussion. So speaking about the ESP, you will need first to know what are the components of the ESP. So the ESP is one sort of artificial lift methods, a multi-stage centrifugal pump. What does it mean, centrifugal pump? It is composed of several stages. Each stage has an impeller and diffuser. The impeller rotates, giving kinetic energy, which is transmitted to the fluid, and the diffuser changes the direction of the fluid movement from the horizontal to the vertical, meaning that the kinetic energy is changed to potential energy or pressure. So this is the impellers attached to the shaft. Multi-stage is composed of multiple impellers driven by a motor. The motor contains motor oil. The pump contains oil fluids, which is very harmful if it enters the motor. That's why we have the seal. The seal hydraulically separates the motor oil from the well fluids inside the pump. Then we have the pump intake or gas separator. The gas separator or pump intake is where the well fluids leave the bottom of the well and enter the pump through these intake holes or through the intake screen. The pump creates a drawdown, meaning that the static pressure in the static conditions or zero flow rate is now becoming the flowing bottom hole pressure. Corrected to the pump depth, it is called the pump intake pressure, PIP. Pump adds head to the fluid, so the fluid will exit the pump with a pump discharge pressure or PDP. Now, the fluid moves from the perforation or the bottom of the well to the pump through these intake holes, through the pump intake to enter the pump and go stage by stage. The fluid flow past the motor is providing the cooling effect to the motor, meaning that the motor is driven by electric power, there is heat dissipation, heating effect on the motor, needs some cooling fluid. The cooling fluid here is the produced fluid past the motor. When the velocity of these produced fluids is not enough to cause the cooling effect to the motor, we may use some sort of smaller tube that is surrounding the whole strength of the ESP to force the fluid to go through a narrower area or a less annular area. So the fluid will have a higher velocity passing through the area between the shroud and the motor than the velocity it would have between the casing and the motor. And by this, we will have more cooling to our ESP motor. Okay, now one of the major problems that we encounter in the ESP operation is the plugging and scaling. Again, the ESP is composed of a multi-stage centrifugal pump driven by a motor. There is an electric cable, a three-phase cable, delivering the electric power from the surface down to the motor. The motor is driven by the electric power. It rotates the shaft of the seal and the shaft of the pump intake. Then this rotation is transmitted to the pump. What happens if I have some debris, rust, sand, or any solid material that can go into this annular space or can accumulate at the intake of the pump? What will happen? This kind of solids that accumulates here will cause restriction to the flow path into the pump, which will cause two things: a decrease in the flow rate and an increase in the motor temperature due to the less cooling. Where are the areas favorable for this accumulation? This is between the motor and the shroud, at the pump intake and intake screen, and inside the pump. Accumulating of solids before the intake, we call it external plugging. External plugging will not hinder the rotation of the shaft, but it will block the flow path. On the other hand, the internal plugging would hinder the rotation of the shaft, meaning that the motor will have resistance to rotating its rotor and the pump shaft. From here, we would understand that the internal plugging will cause a resistance to the shaft rotation, leading to higher motor load and consequently higher withdrawn current by the motor. On the other hand, the external plugging will block the flow path, causing the flow rate to drop and the cooling to decrease, increasing the motor temperature, but due to the decrease on the exerted horsepower by the pump and the motor load would decrease. So in internal plugging, most probably the motor ampere will increase. On the external plugging, the motor ampere will decrease in most of the cases, unless we have a combination of both. As we said, the scale deposition causes plugging, causes also over torque to the motor rotation and the pump to become stuck. Trying to rotate the pump while it is stuck by hard starting, increasing the voltage, trying to apply more power to the shaft to rotate it while the pump is stuck may lead to the shaft to be broken between the motor and the stuck point inside the pump. At this stage, we will have a side of twist on the motor, on the pump shaft before the break point, and we will see examples of this, real life examples of this issue. Moving on, the scaling. Here, I'm differentiating between two issues, the scaling and the plugging. The scaling may be classified into inorganic scales and organic scales. The inorganic scales is related actually with the presence of water. The salts inside the water would cause some scale to accumulate inside the pump, around the motor, or at the intake. So the inorganic scales, mainly we have the calcium sulfate and the calcium carbonate. The organic scales are mainly asphaltene, and the asphaltene is having a higher tendency to form rapidly at the pump intake and inside the pump, and the asphaltene is treated by the diesel and xylene and inhibited by the asphaltene dispersal. How to tackle the scaling problem? We have the inhibition and the removal. Inhibition means what? Means that you prevent the problem from happening at the very beginning. Removal means that the problem happens and you treat it. Here is the classification for the scaling and plugging issue. The main differentiation between both the plugging, due to the poor clean out post workover, causing some foreign materials to enter the pump or accumulate outside the pump. The plugging by poor clean out occurs right after the workover, meaning that before even reaching the design intake pressure, we will have an increase in the intake pressure and the bottom hole flowing pressure due to the blockage at the pump intake by these foreign materials, and we will illustrate this more. On the other hand, the scaling would occur more gradually, meaning that we may reach to the stable running condition, then we will have a sign of scaling by increasing the intake pressure. What are the examples for the poor clean out? Meaning that you did a scrubber run, for example, before running the pump, and you didn't get out of the well your debris and the metals from this scrubber, meaning that you have a frac operation and run the pump right after this frac operation, and some of the proppant or sand used to frac your well is produced back through the pump, causing its plug. Again, scaling and the plugging. The scaling may be classified into the organic scale and the inorganic scale. The organic scale can be inhibited by the asphaltene dispersant. Asphaltene is an organic material that is formed inside the pump components during the pump operation. Usually, you can treat this by the xylene and diesel batches that is pumped into the annulus, or bullheaded by coil tube, or spotted by coil tube, or bullheaded by a surface pump. The scaling also have another type, which is the inorganic scale. It's normally associated with an increase in the water cut in your well, because the water is the one main factor that is responsible of transmitting these kind of salts and materials, and by some chemical reactions, these scales are accumulated. Again, the main two types of the inorganic scale are the calcium carbonate, which is dissolved in acid, mainly hydrochloric acid, and the calcium sulfate, which we have many treatment recipes to dissolve the calcium sulfate with different commercial means. Again, the plugging and scaling may be internal and or external. The internal plugging will lead to hard to start the pump, no backspin. What does it mean? Backspin, we will see it a more illustrative sketch in the upcoming, but the backspin is when you stop the pump implers will rotate due to the fluid fall down back from inside the pump to the bottom of the well. This will act as a rotation of the implers and consequently the rotation of the shaft. It will act as a turbine. Another sign of the internal plugging is the increase in motor load. Why increase in motor load? Like we said, the internal plugging is hindering or resisting the shaft rotation, leading to increase in the required horsepower to rotate the shaft, and consequently increase in the motor load and the withdrawn current. The external plugging, if it is only external, it will not be resisting the rotation of the shaft. That's why the pump may be plugged at the outside and can be soft started, and we may see some backspin if there is a flow path to return the fluid. We have a decrease in motor load, I mean the motor ampere, and the equalization time would increase, and we will see why. So this is typically the roadmap for detecting the scaling and plugging issue and differentiating between them. Let's move on and see some examples from the real life on the plugging and scaling issue. Here we see that the intake screen, this is the intake screen. This is the first door where the fluids would enter the pump string. Here, this is equipped with an intake screen to prevent solids from entering to the pump. However, these solids had accumulated at the outside of the pump, leading to blockage of the flow path and low cooling and consequently pump failure. So that was the root cause for the failure of this pump, the plugging accumulation at the intake screen. This is also some sort of foreign materials that had been captured at the intake screen for a pump with 2 years run life. So within 2 years, these kind of materials had been accumulating at the entrance of the pump or the intake screen. These materials most probably coming from poor clean out or fibers used during some of the well intervention and workover operation. Here is also what we have discussed at the beginning, where the plugging and scales accumulate inside the shroud. Sometimes even after retrieving the pump, it will be hard to retrieve your string from inside the shroud due to the accumulation of the plugging materials between the pump and the shroud, like here. So this is plugging at the pump intake. This is foreign materials accumulating at the pump intake. These are foreign materials blocking the flow path between the motor and the shroud. Okay, now before moving from these pictures, we need to say two notes here. The first one, that whenever you find this kind of foreign materials, you need to collect samples from these materials. Why are we collecting these samples? To do some solubility analysis, to do some lab tests, to understand why these materials is formed. Is it poor clean out or due to scaling? And the other hand, to know how to treat and prevent the reoccurrence of this problem. Okay, so this is definitely not a well fluid. This is foreign material due to poor practices during the workover. This is a combination of plugging and organic scaling. What about the internal plugging? Internal plugging like this. You see, this is the blades of the gas separator. These blades are full of foreign materials that had been pulled or sucked by the pump due to poor clean out after the well workover. Suspectly, this kind of materials is a frac propellant due to running the pump right after the fracking operation without lifting and proper cleaning. This had lead to the sticking of the impellers to the pump diffuser body and the deformation of this pump, leading to the broken shaft. This again, whenever we have this kind of foreign materials detected during the dismantle and inspection and failure analysis, we need to collect this kind of samples to know how to treat and prevent the occurrence of this. Another poor practice, this kind of foreign materials had been captured inside the pump during the dismantle practice after pulling the pump, and this is definitely due to poor clean out and the plugging internally inside the pump. So this is external plugging will decrease the flow rate into the pump. This is also external plugging will decrease the flow rate into the pump and prevent the fluid past the motor. This is internal plugging issue by foreign materials inside the pump components. This is due to poor clean out, leading to overheating of the whole system, which affected even the cable phases. Moving on to the so the previous two topics had been discussing the internal and external plugging by foreign materials. Here, the internal plugging by scaling. Here is an organic scale that is completely plugging the internal parts of the pump and covering the whole area of the impler. Once the well is stopped, these materials had solidified and prevent the pump from restarting again, even by hard start. This is what we have discussed at the beginning, that this plugging or sticking of the pump, when you try to hardly start the pump motor, the motor will try to rotate the shaft, but the shaft will be stuck at another point. That's why the shaft will twist, then break. So these twist marks will be a very big indication that the shaft breaking is not due to bad quality materials, it is due to plugging and internal sticking. Now we have touched the plugging and scaling issue. Let's move to how to tackle this scaling and the plugging issue. So normally we have two methodologies. The first one is the inhibition. How to inhibit? You need first to know what you are going to treat. So by collecting data, collecting samples, do lab analysis, and do compatibility test, you will know how to inhibit the occurrence of your scaling issue. So scale treatment is one way. Scale inhibition is the better way. To inhibit the problem is better than treating it. Inhibition may be by chemical inhibition or mechanical. The mechanical inhibition that is currently arising in the market is using the ceramic coated screen, coated implers and diffuser. The coated stage is usually coated by ceramic, where you will coat your pump stages, the impler and diffuser, to be more smooth and preventing the sticking of the plugging and scaling materials inside the pump. So this is one sort of mechanical inhibition, the ceramic coated stage, and it is one of the advances in the scaling inhibition. The chemical inhibition may be done by the chemical injection control line, and here the injection control line is very small in size. That's why the rates that can be pumped through this control line are very limited dosage and sometimes is not effective. Another alternative to run the chemical screens, which will secrete the chemicals, it will be attached to the pump bottom, it will secrete the fluids, the inhibition fluids, into the produced fluid to inhibit the formation of the scales. In addition to the chemical screen, we can use the scale inhibition squeeze, where you pull the pump during the workover, you squeeze your scale inhibitor, which is designed to last for a few months or up to a year inside the formation, and produced gradually with the production fluid in order to inhibit the formation of the scale. The chemical capsule sometimes thrown or lowered from the annular side in order to act as an inhibitor without having the control line. There is usually no commercial scale inhibitor that is used to prevent the occurrence of different types of scales. So each type can be treated or inhibited by a certain chemical. That's why you need to define which is the main scale composition that you will treat mainly. On the other hand, the treatment may be a chemical treatment or a mechanical treatment. The mechanical treatment is the mechanical backwash, where we will illustrate in the upcoming slides. The chemical treatment for the organic matter is using the diesel, xylene, and mutual solvent mixture. For the calcium carbonate, you can use the HCl For the organic scale, you can use the asphaltene dissolver. So for the asphaltene inhibitor, you use asphaltene dispersant for the asphaltene dissolver to treat the asphaltene compound. Usually, we have the three of them, starting with the diesel xylene to remove the hydrocarbon layer on the scale, which is formed, followed by the acid treatment to remove the calcium sulfate, followed by asphaltene dissolver of the pump not structured after the HCl. Each stage of these stages is used with a certain soaking time. What does it mean, soaking time? The soaking time is where you leave your chemical components or treatment fluid or recipe to get in touch with your scale for a certain time. For example, the diesel and xylene may be left for 1 to 2 hours. The HCl may be done in batches to do a fresh acid with each batch to displace the consumed acid with a fresh acid. Each batch you may have a 30 minutes soaking time also. And the asphaltene dissolver, some commercial products you may have up to 24 hours soaking time without getting harmful to your pump. Again, the main factor or the key message here that you need to know what kind of scale you have in order to know how you will inhibit it and how you will treat it if it is formed. The treatment and inhibition needs to do compatibility test at the lab. For the treatment as well, you need to have a compatibility test with different concentrations of the acids or whatever materials you use to confirm that these materials are not harmful to the pump components. Pump components meaning the metallic parts like the impeller, the diffuser, the pump housing, in addition to the cable and the elastomers inside the pump. So you need to confirm that these recipes are not harmful to your pump. Okay, now we have a pump that is plugged from inside or outside, and we need to pump. The pump is designed to lift the fluids from the bottom of the well up to the surface. But what if you have a permanent check valve? If you have a permanent check valve, you cannot pump the other way around. You cannot pump fluids from the surface down through the pump. That's why a permanent check valve will prevent the backwash activities to remove the scale. In this case, we will use the annulus batches in case the pump is hardly running. In case there is no check valve, we will use the coil tubing backwash, which is better and more efficient than the ball heading. What does it mean, coil tube? You run the coil tube inside the well, you spot the treatment fluid on top of the pump and squeeze them through the pump. This will need to have a flow path inside the pump through these scales in order to dissolve them. Otherwise, you will need to pull the pump. Ball heading will consume some of your acid during its way from the surface down to the pump. That's why the coil tube to spot in place your treatment fluid is better than the ball heading. The mechanical backwash we will illustrate in a more schematic view, but where you shut it down the well or close the well against the running pump. This will lead to a pressured area inside the tubing, and once you stop your pump while the well is still closed, this pressure will push away your plugging materials from inside and around the pump. The plugging symptoms on the pump sensor and ampere parameters. The first, as we said, you will look at the ampere. The ampere, in case of the internal plugging, will increase. In case of the external plugging, the ampere will drop due to the limited flow area and the drop in the flow rate. So for the plugging issue, you will have less cooling. That's why the temperature in blue will increase. The ampere will drop, like we see here. The ampere is in yellow, drop from this value to a more or to a less value of the ampere. An increase and the intake pressure due to the accumulation of the fluid around the pump because they cannot pass into the pump due to the blockage of the flow path. Okay, here this well was suffering from increase in temperature and intake increasing trend and a drop in ampere, which lead to the interpretation that the well is plugged. A backwash is done here, then the temperature had relaxed, the intake could be even lower to lower values till again the plugging issue is repeated and detected by the increase in the intake pressure and the temperature of the motor. So this clear plugging symptoms. Here another more complicated scenario. A more complicated scenario is where you don't have any sensor data. You are only depending on the ampere. Here, in the first run, the ampere decreased gradually, and we have history of plugging in the offset wells of this well. That's why a chemical backwash had been conducted in here and running at the same frequency after the backwash, even we have achieved a higher ampere, meaning that there is a higher flow rate. This can be detected also by the what we said is that back is bent and the pump is restarted hard or soft start. So in addition to the sensor data, the ampere is a clear sign. Here we had successfully removed the scale from inside and outside the pump and managed to reproduce the well at the normal flow rate. So here you look at the pump intake, you look at the temperature, you look at the pump ampere or the motor withdrawn ampere. In addition to this, you look at the flow rate tested at the surface, you look at shutdown after pump shutdown. Is there a quick equalization from the discharge between the discharge pressure and the intake pressure? Does the pump back is bent after the shutdown or not? When you restart the pump after the shutdown, does it require a hard or soft start? All the answers to this question will differentiate between the plugging and the other problems and will differentiate between the internal and external plugging, like we said at the beginning. Here, a very maybe confusing symptoms will be confusing to anyone because here we have the light green is the frequency of the pump, the operating frequency. Here we have been operating at 50 hertz, and by increasing the frequency, even the ampere drop, the intake increased. Increasing the frequency should be associated with a drop in intake due to creating more drawdown. However, after increasing the frequency, the intake increased, the temperature increased, and the ampere dropped. Because of what? Because of the increase of the frequency here had stimulated the accumulation of the plugging materials outside the pump and at the pump intake. After backwash, this is a mechanical backwash carried out in here. The intake had been normalized and the pump motor temperature had been back to normal. In addition to what we see here, that 24 ampere running current compared to only 23 ampere and decreasing by increasing frequency. This is a severe and somewhat strange criteria in here: increase frequency, decrease the rate, and increase in the intake pressure. The key answer here is the pump plug. Here, the last thing, the illustration for the last treatment way. So the treatment, we said we have a chemical treatment, we have a mechanical treatment. We have a chemical inhibition and the mechanical inhibition. We discussed the chemical recipes that we use for the treatment. Let's move on to the mechanical removal or treatment. For the mechanical removal, like we said, here is a pump that is just started. The level of the fluid in the annulus would decrease, and the level of the fluid inside the tubing would increase due to the pump is being operated and lifting some fluid up to the surface. Then again, more drop in the pump in the pump intake pressure in the annulus fluid level, and the tubing now is full of fluid and had delivered the fluid to the surface. Now, what we will do in order to treat the which is proven very successful, in order to treat this accumulation of blogging material here, like we see here, by operating the pump and creating more drawdown, this blogging material like debris, rust, sand, proppant from the frac fluid will move and accumulate around the pump. Here, what is the mechanical backwash is intended to do? That you close against the flow path at the surface. So you close the valve at the surface, the pressure at the surface will start to increase, like we see here. So this high pressure area, the pressure is trapped in here because of the pump is trying to lift the fluids, but the valve here is closed. So this red area, an area of high pressure. Now you keep this valve closed and stop the pump from the surface. From the motor controller, you just turn off your pump from rotating. Once you turn off your pump, these high pressure fluids will flow back through the pump. What does it mean? These high pressure fluids will push these foreign materials back to the bottom of the well, and you will have a clear area around and inside the pump. Here again, let's see the effect of this kind of operation on the running parameters. Here we have a clear external plugging symptoms, decrease in ampere with increased frequency due to the more accumulation, more suction of the fluids, leading to more accumulation of the foreign materials outside the pump, more blockage to the flow path and less ampere, increase in the intake due to the blockage of the flow path, like we said. And then what happens after the mechanical backwash? Intake started to decrease again, meaning creating drawdown. We are producing from the well more cooling because this flow path now is becoming clear. So the blue curve in here had been relaxed from this value around 260 down to 244, and the ampere increase, meaning that we have even at less frequency, meaning that we have more flow rate withdrawn by the pump. Again, the steps for the mechanical backwash. You start up your well till you have the flow at the surface. You close the valve while the pump is running, waiting for the pressure to increase to a safe value. Then stop the pump while the valve is still closed. This fluid will push the foreign materials outside and away from the entry or the intake of the pump. Okay, the clearing of this problem will be detected by, in the next stop, you will backspin. What does it mean, backspin? Again, that this fluid movement will let the impeller of the pump act as a turbine. This will rotate, and this backspin can be measured and monitored at the surface from the VSD or by many other ways. Okay, again, for this to happen, you will need at least to have some flow path to start the production and lifting these fluids into the tubing. If the flow path is completely blocked, you will not be able to do the mechanical or even the chemical backwash, and hence you may need to do a pump retrieval and change out. If these solids are big enough also, this kind of practice may not be very effective. Thank you for your listening and for inviting me today for this interesting topic. You are now free to ask if you have any questions, please. Otherwise, I will quickly recap and we'll end there. So we have like 10 minutes open discussion.
Thank you so much, Engineer Abdullah, for this informative webinar. Feel free if you would like to talk to Engineer Abdullah or discuss something related to this webinar. You can raise your hand. I will allow you to, I will unmute you to speak. Or if you'd like to send a question in the chat area, this is also possible.
Yes, we have a question in the chat box. We mean mechanical backwash is just a common nomenclature for this practice. It's called also reverse flushing or reverse backwash or reverse rotation. Sometimes these steps that had been discussed, we operate the pump after equalization. We operate the pump at the other rotation for some time to ensure that the pump is clear. Normally, this reverse rotation period will be like 10 to 15 minutes. Another question is the foreign particles will slowly accumulate inside. If it is scaling and about chemical reactions, especially for the inorganic scale, these foreign particles will accumulate slowly. However, for the poor clean out, these foreign particles will already be accumulated inside your well and the perforation tunnels. Maybe this debris due to the perforation debris, maybe due to the probant from the frac, maybe due to any other wrong practice that is carried out during the workover without flowing back your well. So these foreign materials will accumulate rapidly, not slowly. Yes, the plugging by foreign materials will happen suddenly, like I have illustrated, and it has been clear from my sketch. For the coated stage, there is a question. For the coated stage, it's like a ceramic. You know the ceramic coated pen. The difference between the ceramic coated pen and the aluminum pen it's more soft, more smooth, chemically and mechanically preventing the accumulation of the solids on the surface of this kind of metal. So it is coated by ceramic from inside on the rotor and stator parts. For the ampuller and diffuser, I mean, sorry. Not rotor and stator. The rotor and stator is for the motor. I mean the ampuller and diffuser. Yes, there's a very good question actually. Does high frequency and low ampere always represent internal plugging in the pump? No. High frequency, low ampere may be due to the pump off condition. What does it mean, a pump off condition? A pump off condition is where you operate your pump at a higher rate than the rate that the well can deliver. So the fluid in the annulus will be produced, followed by the gases in the annulus. The gases in the annulus will lead to the heating of the motor and the drop of the ampere. So pump off, gas lock, and external plugging may be the reasons for the same. How can we differentiate? For gas lock and a pump off, you will have quick equalization. Once you stop the pump, there is equalization in pressure between the discharge and the intake of the pump. There would be a back spinning of the pump. That's how you differentiate between the plugging and the other symptoms that may have the same symptom, other problems that may have the same symptom. Who determines the best chemical injection we should use? He is the chemist. The chemist, mainly with the lab chemist, will do the compatibility test, will do the solubility test, and so on. So that's why you need to have a track of the kind of plugging and scaling you have for each well, also for each reservoir, because you may have the repeated problem to other wells producing from the same reservoir. Yes, and consequently, you will need to keep a track of the plugging and sample analysis that you have. So this is the answer for who will determine the best chemical injection. Does the mechanical backwash affect the pump life? Maybe if this no flow period where you shut in the well, it should be between 15 to 20 minutes. However, if this no flow period lead to very high temperature due to no flow, this may be affecting the pump, but it may be a solution as well to your external plugging. Also, the chemical backwash also will affect the pump components in different strengths. Yes, here is another question. If pump continues plugged within few days and scale plugging only stages, not accumulated in tubing, what in your advice for such case? Mean time between failure is 1 to 3 months. So the scale and the plugging only in the stages and not accumulated in the tubing. So again, you have your mean time between failures 1 to 3 months. So you retrieve a lot of pump, you collect a lot of pump strings, you collect samples, do compatibility analysis, and do inject the right inhibitor. I recommend to have a scale squeeze, and the coated stage may be a very good solution to this case. Because as you said, the plugging is only at the stages, and the coating is done to the stages. That's why it will be very effective to your case, Hazim Hussein. Is it safe to do reverse rotation if external plugging occur? Yes, it is safe, but may lead to some detrimental effects to the pump component, especially that we bypass the discharge pressure trap and the high TM trap to allow the pump to pressure up the tubing. In addition to this, if the tubing is not clean from the inside, this pressuring and depressurization of the tubing may lead to even the increase of the problem due to this rust inside the tubing fall back onto the pump, at the top of the pump and inside the pump. No concern about the motor overload. The concern is about the motor underload trap due to closing against the running pump will lead to underloading condition, and the underload, the discharge, and the high TM. All the traps are bypassed in this case. The sand I consider is plugging. From my point of view, is not scaling. It will plug, not a kind of scale. In this case, you need to use the sand screens. You will need to use gravel pack if applicable. You need to use any kind of sand treatment to the sand production. If it is production from natural sand, if it is proven to production, you will need to properly design your frac to withstand the high drawdowns and to clean your well after the frac for 2 to 3 days by nitrogen lifting before installing the pump. So there's a question here. As the flow rate will decrease due to the issues, and we will calculate and analyze the nodal system, do you have experience how much prediction of success to improve oil after tackling the scaling? So it depends on your well capability. So if you completely treat your problem, you will back to your original rate. So it's all about how much drawdown the pump can create and the productivity index of your well. How do these costs compare to the potential losses incurred if the problem persists? So it will not only cost you deferment, it will cost you also the replacement of the pump, because the plugging is one of the main enemies to the pump, the ESP pump, plugging and scaling and sand production. If you don't treat this, you will lose your pump very frequently and spend more on the pump replacement. There are cost-effective long-term strategies for preventing scaling and plugging. Yes, it has been already discussed. If you have chemical treatment, you have mechanical treatment, you have chemical inhibition, you have mechanical inhibition, and we have discussed a number of chemical inhibition varieties like capsules, chemical screens, chemical inhibitor in the control line, and scale squeeze. I mean scale inhibitor squeeze, but it is commonly called scale squeeze. Yes, the ceramic coating is effective in almost all of the scaling and the plugging types, because it works on the surface of the impler and diffuser to prevent the accumulation chemically and mechanically on the pump components. So the scale batches in the casing side, yes, it sometimes work if the pump is running. it will improve its running parameter and dissolve the scale, because you need the pump to be running in order to circulate these chemical batches from the annulus into the pump. But sometimes also, yes, I agree with you completely that it will push all the rust into the pump. It will cause also detrimental effects on the cable and the pump components. The acid will be consumed. The acid will be consumed during its journey from the surface down to the pump intake. But here I'm speaking about these batches of diesel and xylene in order to reach to the pump intake if there is a check valve. So I'm not speaking about acid. The acid in the annulus, I'm completely against it, and I didn't try before. But other sort of non-damaging dissolvers like diesel can be pumped. Also, the inhibitor, the non-corrosive, non-damaging inhibitor, can be pumped as a slipstream or as at a very slow rate in the annulus. The same concept as the pumping through the control line. So here, باشمهندس عيد, I'm speaking about the inhibitor and the diesel into the annulus. The diesel into the annulus may be not very effective at the beginning, because the diesel will be by buoyancy will be at the top. Also, the kind of inhibitor that you pump need to be higher in gravity than the well fluid in order to reach to the pump intake very rapidly. But we have used this slipstream and pumping into the annulus before, but not the acid. I completely agree with you. It's not effective for the acid. Yes, there's a question to remove the screen from intake or gas separator. Use more stage in design and run with low frequency. Use gas separator as intake. Yes, يعني there is no, we cannot comment Harshad Sami on your recommendation to remove the screen, but for the poor clean out and the heavy solids, instead of when you remove the intake screen, you will have these all solids, especially after frac, all these solids will enter into the pump. I completely agree. There's a question from A Tamam. How can we select the suitable scale inhibitor from the offset wells? As we said during our session, you need to collect samples, track your sample analysis, know which reservoir has a tendency for which scaling. And for asphaltene, there is asphaltene tendency tests that can be carried out on the produced fluids as well, simulating the bottom hole conditions. So can carry out asphaltene tendency test. You know your water have tendency to which kind of, if the well is in a water injected reservoir and you have water production, this will lead to inorganic scales like calcium sulfate and calcium carbonate. So you will focus all your inhibition to these, especially if this is supported by samples from offset wells. Engineer Hazem Hussein, is there any practice scale appearance with pressure drop, or what the condition of scale appearance during well life? The question is not very clear actually. Yes, you mean the condition. So the scaling always have a favorable conditions in terms of the temperature and the pressure. Yes, additional pressure drop has proven more tendency to the scaling. Higher temperature has proven more tendency to the scaling. So it's all about the chemical composition and the downhole conditions in terms of pressure and temperature. Agree with you, higher pressure drops may cause a higher scale tendency, but it depends on the kind of scale and the chemical composition of the produced fluid. In addition to all this, there may be incompatibility between the inhibitor that is pumped through the control line and the the scale inhibitor and the produced fluid. This incompatibility may lead to this incompatibility will lead to the formation of byproducts that may accumulate inside the pump. But again, some scale types may be enhanced by the additional pressure drop, or the scale formation may be stimulated by the extra pressure drop and the higher temperature. But the pressure itself is having two effects on the solid precipitation. Two effects. It's two vice versa. One effect is to change the saturation, the change of the saturation pressure when you change the pressure and temperature. And the other change is the amount of water that will be evaporated if the temperature is elevated. For elevated temperature, some pressure may be applied. The higher pressure, the higher condensation for the water. The higher condensation will allow more solids to precipitate. On the other hand, decreasing the pressure will change the saturation pressure. For the type of pump will affect for the scaly wells. Yes, so the type of pump may affect the detrimental effects on the pump by the scale, like having narrow clearances may get severely affected by the scale due to narrow clearances stuck very rapidly, unlike the other. But the scale itself is about the conditions and the chemical composition. Some pumps like the mixed flow pump and the bigger pumps like the 500 series is better handling solids than the 400 series due to the higher clearances and the bigger size. However, this only the effect on the pump, not the formation of the scale or not. But the effect of this scale on the pump will be completely affected by the pump size and the design. On the other hand, the mixed flow for the plugging, I'm speaking about the scaling. From the plugging point of view, the mixed flow can handle the mixed flow pump, and the bigger pump can handle more solids and cannot be plugged by the poor clean out very rapidly like the smaller pump. Okay, I hope this is clear. Any other question, Rashad? Some you can allow for opening the mic if you.
Yes, no problem.
Yes, okay, because
yes,
we have open discussion.
Okay, we have I think Engineer Saleh Ahmed. I will unmute your microphone to speak out.
Assalamu alaikum.
Alaikum salam. Go ahead, Engineer Saleh. Please keep the conversation in English so all can get your question.
Yeah, thank you, Engineer, for your topic. My question is for if I have one well low influx, a low pressure, and I have a scale for this well. And I have two options for I use for a small pump and go with a big pump. Which is better?
Yes, as we said, Bashmhandis Saleh,
Yeah.
the bigger is always better as long as it fits into the clearance inside your well. I mean, by the clearance, the casing size. The casing size can accommodate the pump and the cable and all this stuff inside your well. If the casing allow, the bigger is better as long as it can fit into your well and it can handle your well rate within your pump range. I mean, you will be operating not in the down thrust range. So as long as the pump can fit into your well and can fit into your well productivity, bigger is always better. Okay, is it clear, يا باشمهندس صالح؟
We have another
Uh,
question. Yeah.
yeah, it's clear. So we go with a big bump, يعني, inshallah.
Yes, bigger, inshallah.
Okay. Thanks, Sarah, for your question. Engineer Muhammad, you raised your hand, so feel free to unmute your microphone. Engineer Muhammad, please unmute yourself.
شوف يا محمد.
Yeah.
ورحمة الله وبركاته. Can you hear me? Can you hear me?
A little bit difficult because of internet instability at your side. If you'd like to type your question in the chat area, it would be better.
Can you hear me? I have a question, Abdullah.
Yeah, go ahead. Go ahead.
I have a weakness in the internet. Is we have some wells here in Yemen. Sometimes these wells have stuck due to some wax and scale. We are normally using diesel for flushing the well. Actually, it works, and we bring the wells. My question is, the diesel that we are using here is working tolerant. Is that right? And some well working. If we by percentage, I should pump it with through and it will. Just this is the.
Yes, so what I understand from your question that you pump diesel, it works for some well, it doesn't work for other wells. Again, the key answer here is the compatibility with your fluids and with your scale, and how far this scale had been forming into your pump components. So again, if you have this scale accumulated for a long time before you started to intervene, especially if the pump didn't trap for quite long time, and you didn't detect this problem because the first detection, if you don't have right trap settings in terms of temperature, underload, overload, and so on, the pump didn't trap. It will continue to plug till it is completely plugged. With the next trap, you try to start your pump, it will be stuck. It will be a no-go, especially due to the accumulation of the scales and the plugging inside the pump. In addition, also to the deformations that may be happening due to the elevated temperature, maybe changing the dimensions of your if the temperature reaches a very high values, it may lead to a stuck due to overheating of the pump component and the detrimental effect of the motor, so it can be not started due to also maybe trapped due to motor stall. Okay, so if you allow the scale to build up, it will be like cancer, will not be easy to remove. So it will work for some wells, for other wells may not work, depending on the types of scale. Maybe the wells where this diesel will work is having no water cut, so the only scale type in there is organic scale or asphaltic. On the other hand, the other wells may have some water cut, so there is a combination between organic and inorganic scale. Well, this is my answer. Try to get samples, collect data about water cut, the formation or reservoir you are producing. All this stuff you will need to know about in order to put your hand on the problem and treat it. Okay, is there any other questions?
If any other question, please type in the chat.
Okay, if no other question, I will recap very fast.
Okay, no
So
problem.
today's session, we have been discussing the plugging and scaling as two different issues. We have discussed the scaling and plugging the problem, the differentiation between both types of scales, and how to tackle them. Tackling means prevention or inhibition and treatment. We have spoken about one of the advances in the scale inhibition, like chemical screens and coated stages. We have discussed the components of the pump, multi-stage centrifugal pump. Each stage is composed of impeller and diffuser. The pump is driven by a motor, electric motor, three-phase electric motor that is fed by electric power through a three-phase electric cable driving the seal, gas separator intake, and the pump. The plugging may be internal and external. We said that the main factor that is providing the cooling effect to your motor is the fluid flow past the motor, and if this is not fast enough, you will need to install shroud. Shroud will narrow the area around the motor and allowing more solids to accumulate between the shroud and the motor. We have seen this example of the inorganic scale, and we have discussed the effect of the scale on the pump operation may lead to the stuck pump, unable to rotate the pump shaft, and finally the shaft may be get broken. We have classified the scale problem into inorganic scale and organic scale, and the tackling into inhibition and removal. The organic scale, treating with xylene, diesel, and natural solvent. Inorganic scale, classified in calcium sulfate and calcium carbonate. Calcium carbonate can be treated by acids like hydrochloric acid. Calcium sulfates can be treated with many commercial products. We have discussed the plugging due to poor clean out. It is internal and external, and we have differentiated between both. We have seen some examples about each type of external plugging by foreign materials, internal plugging by foreign materials, internal plugging by organic scale, and the inorganic scale will form a layer on the impeller and diffuser. We have seen this example of the twisted shaft due to the trying to rotate the pump while the shaft is stuck. Tackling the problem, inhibition, mechanically, by the coated ceramic coated stage, chemically, by control line, which provides low rate chemical screens, scale inhibition squeeze before running the pump on the workover rig, chemical capsule treatment by mechanical backwash or chemical backwash. You may use one of these components of the recipe or the three of them if you have a combination of scale types. We have seen that the permanent check valve will prevent the normal straightaway scale treatment. If no check valve, you can use a coil tube or the bullheading. Okay, again, as our colleague has asked, the annulus batches will be very detrimental to your pump components and will not be successful if you use acid. Annulus batches may be used with diesel xylene natural solvent, especially with diesel, or may be used with the inhibitor itself, not with acid. We have seen the examples of the pump plugging symptoms on the sensor data and on the pump ampere, and the successful clearance of the pump after the mechanical or chemical backwash. Here, the chemical backwash, here, mechanical backwash carried out, here, chemical backwash carried out based on the ampere only. All of them had been successful. We have discussed the schematic for the accumulation of foreign materials around the pump, which is increased by production. Here, normal drawdown. After this accumulation, the fluid level will rise due to no flow going or low flow going into the pump, low cooling, high motor temperature, and so on. Then you can close against your running a pump, stop the pump after 10 to 15 minutes, measure your back spin, and the pump may get clear 1 or 2 times. All these solids may be dropped into the sump. Okay, thank you for your interest. What are the chemical capsules and chemical screens? Chemical screens are especially designed chemical inhibitors that is attached to the bottom of the pump and secretes the chemical inhibitor or the scale inhibitor into the well flow as the fluid flow past these chemical screens, and they are designed to last for the whole pump run life, or at least for 6 months to 1 year. Chemical capsules are pieces of encapsulated scale inhibitors that can be dropped into the bottom of the well through the annulus in order to inhibit the scale accumulation with the flow. Okay, thank you all. If there's no more question, I will stop here, and thank you again for your understanding and your attendance.
Thank you so much, Engineer Abdullah, for this informative session. Also, I'd like to mention that the only way for improvement is feedback. So please take a few moments to fill in the feedback form that I sent in the chat now. Your opinions, suggestions, and thoughts are important for us. Also, I'd like to remind you that we have an ESP course training program that is going to start on the 2nd of December and is going to be taught by Engineer Abdullah as well. This course lasts for 5 days, handling the design, operation, and troubleshooting of the ESP. Today's webinar is just few information, a little information about the ESP. If you'd like to get more information, detailed course through the design, operation, troubleshooting, I really encourage you all to register in this program. We have a good discount for the early bird. You can get the course at $175 instead of $250. And we also have special discounts for our ambassadors as well, who have already registered with us in previous courses. So if you would like to register in this program, which I really recommend, and I recommend Engineer Abdullah for this course too, please take a moment to register through the link that I sent in the chat area. So two main tasks. The first, don't forget to fill in the feedback form. This is the only way for improvement. Second thing, if you are interested in ESP towards an application design, application possession, or something like this is your first step. Register in the course, get the discount, and start your learning journey with OPA Energy. So the link is now in the chat area. Thanks for your time. I see that someone asked for the presentation, so no worries, because this webinar is live streamed and is available on our YouTube channel. You can revisit this webinar 100 times as you wish. Thanks again. Thanks everyone for joining us today, and we really look forward to seeing you in our upcoming webinars. Have a nice day. Thanks.